Welcome back to my YouTube channel. Today we will discuss about sandwich theorem. F of x, g of x and h of x are three functions such that f of x less than or equal to g of x less than or equal to h of x at x is equal to a. Now represent f of x less than or equal to g of x less than or equal to h of x in the form of a diagram. Here this is x-axis and this is y-axis. This is a graph of three functions. Y is equal to f of x, y is equal to g of x and y is equal to h of x. Now take one point, let's say a. If you draw a line at x is equal to a, all these three functions are very close. The difference is very small. All these functions are at same point. In this case, we observe that as it reaches to x is equal to a, almost three functions are at the same point. Is it clear? Here f of x, g of x and h of x are three functions. G of x lies between f of x and h of x. These three functions at x is equal to a. These three functions are very close. The difference is very small. All these functions are at same point. Is it clear? Now apply the limit to these functions. Let limit x approaching to a, f of x equals L. Limit x approaching to a, h of x equals L. Apply the limit on f of x and g of x at x is equal to a. We got the value L. These two values are equal. In that situation, limit x approaching to a g of x is also L. If limit x approaching to a f of x equals limit x approaching to a h of x, that is nothing but L. In that situation, we say that limit x approaching to a g of x is also L. This is because f of x less than or equal to g of x less than or equal to h of x. G of x function lies between f of x and h of x. Here x is equal to a. These three functions are almost in the same point or closer. That's why we here write it as f of x less than or equal to g of x less than or equal to h of x. Limits of both the functions f of x and h of x are the same. Here h of x are the same. Then the same value is for the middle function. What is that middle function? G of x. This is not g of x, this is h of x. Limit x approaching to a f of x equal to L, that is equal to limit x approaching to a h of x. Limit x up, these limits of these two functions are L, then without any calculation we write it as limit x approaching to a g of x is also L. If the limits of both f of x and h of x are equal, no need to find the value of the function g of x separately. This happens only when limit x approaching to a f of x and h of x are same or L or the same value. Then limit x approaching to g of x is equal to L. This is a sandwich theorem. If we don't get this equal value, then we can't make any conclusion in that situation. Is it clear? Now let's understand how we can use sandwich theorem on our problems, in our problems. Example, limit x approaching to 0, x square into sine 3 by x. This only one function is given. Here we use sandwich theorem instead of directly applying the limit. The sandwich theorem is applied only when we can have three functions. But here given only one function. Here only one function is given. Now let's find the remaining two functions on LHS and RHS of this function. Is it clear? RHS of this function means limit x tends to 0, x square into sine 3 by x. Is it clear? Solution. We know that range of sin x lies between minus 1 and 1. The value of sin x is between minus 1 and 1. So we can write minus 1 less than or equal to sin 3 by x less than or equal to 1. So sin function lies between minus 1 and plus 1. What is our sandwich theorem? G of x lies between f of x and h of x. The function is in this form. So our question we converted into the form of minus 1 less than or equal to sin 3 by x less than or equal to 1. So our question is x square into sine 3 by x. Here we write only x in sine 3 by x. So multiply this inequality by x square. So inequality become minus 1 into x square, that is equal to minus x square, less than or equal to x square into sine 3 by x is equal to x square into sine 3 by x, less than or equal to 1 into x square gives x square. Apply the limit. Limit x tends to 0 minus x square less than or equal to limit x tends to 0 x square into sine 3 by x less than or equal to limit x tends to 0 x square. Sandwich theorem says that if we have the inequalities in this way, what is that way? F of x less than or equal to g of x less than or equal to h of x, then no need of finding the limit of g of x. Here, what is that value? Limit x tends to 0 x square into sine 3 by x. Instead of that, if we find the limits of f of x and h of x and getting the same answer, then that value for that limit is applied to the middle function. What is that middle function? G of x. Is it clear? This is not g of x, this is h of x. F of x and h of x, the limits of f of x and h of x are equal, then that value is applied to g of x also. Is it clear? Then limit x approaching to 0 minus x square less than or equal to limit x approaching to 0 x square into sine 3 by x less than or equal to limit x approaching to 0 x square. This is f of x, g of x, h of x. Find the limit of f of x and h of x and both of them are equal. Then that value is applied to g of x. Is it clear? Here, instead of finding the limit of the function, limit x approaching to 0 x square into 3 by x, we just find the limits of these two. Limit x approaching to 0 minus x square and limit x approaching to 0 x square. What is limit x approaching to 0 minus x square? Here we apply the limit directly. What is 0? That is 0. Limit x approaching to 0 x square is, here also apply the limit directly. That is equal to 0. Here we see that both of the limit values are equal. So the LHS and RHS limit values of the function are equal. So that value is same for the middle function also. Is it clear? So the limit x tends to 0 minus x square less than or equal to limit x tends to 0 x square into sine 3 by x less than or equal to limit x tends to 0 x square. So these two are zeros. So both of them are equal. So that value is applied to the middle function, that is g of x. So limit of f of x and h of x are equal, then that limit is applied to g of x also. So limit x tends to 0, x square into sine 3 by x is also 0. This is how we apply sandwich theorem in problems. Is it clear? Thank you.